So we visualize this three-dimensional space, which we call the momentum space. So the three axes are your nx, ny and nz. So now if you try to visualize, you start by visualizing a cube of side 1 unit. So the volume of the cube is 1 cubic unit. The dimensions are 1 by 1 by 1. So you will find that you can put an atom at the edge of the cube with coordinates 1 comma 1 comma 1. Here remember that the axes represent the quantum numbers. So you and the quantum numbers can only take positive integer values. So you can only have an electron or an ion at positive integer values, say 1, 2, 3 and so on. You cannot have something at 1.25 or 1.75 for example. So if you take a cube of unit dimension, the only coordinate between 0, 0, 0 and 1, 1, 1 where you can actually have an allowed energy state is 1 comma 1 comma 1, because your quantum numbers cannot be 0, they start from 1 and they cannot be any decimal value either. So when you go to a cube of side 2, 2 cross 2 cross 2, there are 8 possible corners and you can have an atom located at any of these 8 corners. 1, 1, 1, 1, 2, 1, 2, 1, 1, 1, 1, 2, so on up to 2, 2, 2. And they have been divided into 4 categories based on the total energy. So if you take the total energy as nx squared plus ny squared plus nz squared, this will give you 3. Any of these will give you 6. This will give you 4 plus 4, 8 plus 1, 9. Any of this 3 will give you 9 and this will be 12. So there are 4 possible different energies, but we are not going to consider the energy as such. We will consider the number of allowed states. So if you take a cube of side 1 cross 1 cross 1, you had only one allowed state. If you take a cube of side 2 cross 2 cross 2, that is a cube of volume 8, you have 8 allowed states. Similarly, if you take a cube of side 3 by 3 by 3, that is a cube of volume 27, you will have 27 allowed possible states. So starting from 1, 1, 1 up to 3, 3, 3. You will have 27 states and so on. So basically what we find out is the number of levels, allowed energy levels between n and n plus dn is the volume enclosed between n and n plus dn. Or if you want me to put it in simple terms, you take a cube of size n by n dimensions. If you take a cube of volume n raised to 3, then there are n raised to 3 possible energy states which can be fit within that cube. So how is this knowledge going to help me? What I want to find out is the number of energy states between E1 and E2, right? So if I model this energy levels as spheres on this momentum space, so let's say this inner grey color sphere represents the set of all energy states with energy E1, and the outer pink color sphere represents the set of all energy states with energy E2. Now if I want to find out how many energy states are there between E1 and E2, all I need to do is calculate the volume difference between the pink sphere and the grey sphere. So that difference will tell me how many energy states exist between E1 and E2. So that is the approach we are going to follow. So I will quickly repeat. So what we did is we considered a three-dimensional space where the three axes represent our quantum numbers. So because we are talking about quantum numbers, the coordinates will only be integer values. We do not have decimal values. So you take a cube of side n cross n in this space. You will notice that there are n cubed possible allowed energy states starting from 1, 1, 1 up to n, n, which are allowed. So what does this tell us? The number of allowed energy states within from E1 to E2 is simply the volume difference between a sphere of energy E2 and a sphere of energy E1. What do I mean by sphere of energy E is the surface of a sphere such that any point on that surface has energy E. So let's say I'm talking about energy 3h squared by 8 ml squared. Then any point whose energy will be 3h squared by 8 ml squared will lie on that sphere, and the only such possible point is 1, 1, 1, and so on. So if I want to find out the energy difference between E and E plus dE, let's say the corresponding energy levels are N and N plus Dn, I simply need to find out the volume difference. That will give me the number of energy levels available.